Hi everyone, in this video we are going to talk about the titration curve of polyprotic acids. So it's important for you to understand the various parts of this graph before you watch this video. So if you haven't done so, please refer to the previous video on the titration curve of acid-base equilibrium. Alright, so over here we have this acid over here. Alright, this is a diprotic acid and this is called ethane dioic acid. And so what happens, alright, is when we start off with just ethane dioic acid, it has a certain pH level over here. So what is present at this point is simply the ethane dioic acid. And as we add some sodium hydroxide, the shape of the graph will look something like this until it goes vertically up. So at this point in time, since I had 20 cm³ at the start, they have the same concentration, this should be 20 cm³. So it will spike up first, and at this point I would end up with the other product, which is this first product here. And what you realize is that at this point of 10 cm³, right, there is an equal amount of ethane dioic acid and its first conjugate base. And so this is our maximum buffering capacity, where this pH is equal to pKa1. Okay, and so it will shoot up and then it will flatten again and then it will shoot up second. Right, so this part is at 30 cm³. This final part where it shoots up again is at 40 cm³. Right, and so what we have over here at the end is just this compound with both acidic groups deprotonated. Right, so at 30 cm³, this point will be our pKa2, which is the pKa of the second equation. Alright, and so after we cross 40 cm³, and then it will just go flat, and this will be characteristic of just dominated by your NaOH. Right, so this is how it goes. Usually when it is a diprotic acid, we will have a maximum buffering capacity that uses pKa1. The first spike, the second pKa2 value, the second maximum buffering capacity, and over here. So what we want to do is, whenever we look at a question, alright, we want to look at what this species exists as, where in different pH levels. So we can simply look at the pH level of this graph. Right, so let's say the pH is here, we know that we have mostly this product over here. So if the pH level is here, we somewhere here, we know that we predominantly only have the first a mixture of these two. So it depends on what pH the system is currently at, okay, where it will tell you what are the species present. But usually when we do titration, right, we just want to add NaOH and see how this graph actually shapes out. And so there is also one tiny part of this graph that some people will get confused, which is this portion here. And usually when people see this part of the graph, they'll ask themselves, okay, this is I'm going to do salt hydrolysis here, so the solution is going to be alkaline. But that might not always be the case, because let's say this pKa2 value is below 7, alright, which means this will never be above 7. So instead, this is actually an acid, a dissociation of a weak acid. So what do I mean by that? Okay, let's take a look at this structure here. Right, so this is what we have at our first equivalence point. And notice, this group here, this O- over here, is able to act as a base, whereas this OH here is able to act as an acid. So what we want to do is to compare the Ka and the Kb value. So Ka versus Kb. Alright, so when you compare the Ka versus Kb, which is linked together by Kw, you will be able to find out whether this acts more like an acid or a base. So if the Ka value is larger than that of Kb, what will happen is that this will act more like an acid than a base. Alright, vice versa. So using that, you will know which equation to use. If you notice that it acts as an acid, then you will use the acid dissociation constant, alright, to solve for the pH. If you think that you realize that it acts more like a base, you'll use the base dissociation constant to study the pOH and hence the pH. So this is the part that confuses a lot of people, but ultimately at the end of the day you must ask yourself, after you pour these things together, what is left in the mixture.